Okay, today we're going to talk about photons leaving anything, whether it's a planet, a star, or a galaxy, or maybe even the universe. We call this the galactic gravitational electromagnetic energy. And what we're concerned about is that when photons leave each of these structures, galaxies or planets or whatever, we wonder how much of their energy remains with the galaxy. Because after all, if this is our galaxy or planet or whatever, if the photon is here, it's got a certain amount of energy, but gravity tends to reduce gravitational potential energy if that's all we're concerned with. The energy that the photon has here and the energy that the photon has here is totally different. This photon energy will be a lot less energy than this is. And we wonder, where did that energy go? Well, of course, it has to remain with the galaxy, the source of the gravitational potential energy that is taking away the energy of the photon between these two positions right here. This is, by the way, we also discussed gravitational waves, since they move at the speed of light. Also, they must have a certain amount of energy. Gravitational waves would have a certain amount of energy here, and gravitational waves would have a certain amount of energy over here. And we would wonder where did that energy go? If it's got $10 of 10 joules of energy here, whatever, and it has 4 joules of energy over here, whether it's a gravitational wave or a photon, an electromagnetic wave. Where did the joules go? And they must have remained with the galaxy or in the space surrounding the galaxy there. And that's actually the concern we have here, is the idea that the photon is leaving the energy, is depositing the energy in space, because after all, after a while, the photon is so far away from the object that it escaped from, that if the energy has to travel, I assume by the speed of light, it's gonna be in transit in space, trying to get back to the galaxy here. So that's what we're mainly concerned with. The calculations here are the energy initial minus the energy final of the photon is right here, and that has to be diminished by, we assume, just the gravitational energy here, assuming that there's a neutral charge on this galaxy. And even if it wasn't neutral, photons do not interact with don't diminish with charged particles there. So here's our gravitational energy right here, and I assume that the energy here would be 0 to find out how much energy would be left here. And of course, the energy that would be left, if the energy here of the photon or gravitational wave is 0, then the entire photon is left with the galaxy. All the energy of the photon is left with the galaxy, or in the space surrounding the galaxy right here. Okay, we put some numbers in. This is actually not really a complete lecture right now. I just wanted to make some notes for me later on, but I wanted to make sure I get it out and we discuss how photons leave energy in their wake in the space and return it to the object from which they were trying to escape. Alright, thank you for watching, and I hope you enjoyed this video.